So the equilibrium constant is only affected by temperature. Other factor does not, they change the concentration but does not change the value for, because Kc or Kp is calculated at equilibrium, means when there's a balance. So if we use a catalyst or if we add reactant or remove product, so that these all things can alter the mole ratio, but it does not alter the value for Kc or Kp. The only factor, only thing which change the value for Kc and Kp is the temperature. Some questions now related to this Kc and Kp. First MCQs and then structure questions also will discuss. Multiple choice question. The equation for manufacture of ethanol by reaction by uh, manufacture of ethanol by reaction of ethene and steam with the catalyst phosphoric acid. The highest equilibrium yield for ethanol. It's a reversible reaction as well as exothermic. If you recall the factor which affects the position of equilibrium, for exothermic reaction, we prefer low temperature, and for endothermic, we prefer higher temperature for greater yield. And for pressure, how the pressure effect, increase in pressure shift the equilibrium towards side where number of moles are less, and decreasing a pressure shift the equilibrium towards side where number of moles are more. So what could be the answer here? For 1A, so C will be the right answer. Why? Because if we decrease the temperature, increase the pressure, both leads to, because it's an exothermic reaction, to decreasing temperature and increasing the pressure will leads to a higher yield of ethanol. Now, what are the units for Kc? So to write the unit for Kc, first you have to write an expression for Kc for this reaction. So which is product divided by reactant. So product is C2H5 and divided by reactant, it will be C2H4 in a square bracket and H2O water will be there. So this will be mole per dm cube. This one is mole per dm cube and mole per, so that will cancel. So it will be dm cube divided by mole inverse. That's why B is a, yeah, B is the right answer. That's correct. The equilibrium constant for this reaction increases when, means the value of the Kc. For endothermic reaction, increasing a temperature increases the value of Kc. For exothermic reaction, decreasing a temperature will increase the value of Kc or Kp. So how the value is affected? So pressure won't affect, catalyst does not affect, changing the concentration does not affect. So only thing which affect is the temperature. And what we should do, because for endothermic reaction, increase in temperature, increase the value of Kc or Kp, and exothermic, decreasing a temperature increases the value. What's the answer for this? Silver oxide decompose on heating. What is the expression for equilibrium constant Kp? Keep in mind, you have to know that whether it's a homogeneous or heterogeneous equilibria, solid, liquid, and aqueous, you don't take consideration. Solid, solid, and gas. So actually it should be question 2. The answer should be D. Why D? Because it's a heterogeneous equilibria, solid, solid, and gas. So you need a pressure due to oxygen only. Yeah, sorry, C, because 3 options are given. I thought this was the last one. Yeah, C. C in the, I thought this one is the last written, so that's why I was saying D, but only 3 options are copied. So what is the value for Kp in this numerical value? Dry nitrogen tetroxide forms equilibrium mixture with nitrogen at equilibrium when the temperature is 400 Kelvin. The equilibrium partial pressures are shown. So they will directly give you the partial pressure. Numerical value of Kp. So you will write first the product, which is NO2 raised to power 2 divided by reactant, which is N2NO4. And it is 0.4.18 square divided by N2O4 concentration, pressure was 0.365. So you will divide them, you will get the final answer, and the final answer is D here. The equation for the following, the equation for equilibrium between nitrogen and oxygen may be written in 2 ways. The standard enthalpy change, or a delta H, for the reaction as shown for first equation is 180 kilojoule per mole. What is the standard enthalpy change for a reaction shown for the second one? Standard enthalpy change. Question 4. What could be the answer? The delta H enthalpy change. Yeah, B is the right answer. Why? Because look, when you are using one, what you did, when 1 mole of nitrogen react with 1 mole of oxygen, it formed 2 moles of nitrogen monoxide, and the endothermic reaction, it absorbed plus 180. But now half moles are there and you're forming 1 mole. So how much energy it will absorb? It will absorb 90 kilojoule per mole. The equilibrium mole fraction of NO is increased by how we can increase the amount of NO. What we can do? Increasing temperature, decreasing temperature, increasing total pressure, decreasing pressure. The reaction is endothermic. So if it's an endothermic reaction, when the reaction is endothermic, increase in temperature, shift the equilibrium towards right hand side. So you will get higher amount of product, which is NO in this example. Which of the following expression is correct? Like the forward and the backward react Kc, the first reaction Kc and the second reaction Kc, how they are related with each other. So what you can do, you can write an expression. So you can simply write equation for equilibrium for the first one. When I write Kc for the first reaction, it is NO square divided by N2 concentration and O2 concentration. When I write for the second reaction, I will say this as K1 because equilibrium constant is K1. So K2 is equals to NO. This will be N2 raised to power half or square root and O2 raised to power half. So how I can convert this expression into this one? If I take square root, when I take square root, so I can say square root of K1 is equals to NO because square root and root will cancel, and this will be N2 raised to power half and O2 raised to power half. And this NO, N2 raised to power half and O2 raised to power half is actually equal to K2. So we can say K1 or K raised to power K1 raised to power half is equals to K2. So which one it matches with? Or other way around, if I square this, so I can say K1 is equals to K2 square. So both ways are right because it's written K2 half. No, it's not K2 half. It's K1 half is equals to K2. So C is the right answer. Reason why it cannot be B, because when we wrote the expression here, look, the K1 was NO. When we write the expression K1 is equals to NO square divided by N2 and divided by O2. If I square this and K2 was equal to NO divided by N2 raised to power half and O2 raised to power half. If I square both sides, so when I square, this expression will turn as this one. So it means K1 is equals to K2 square. No, so it's a power, not the coefficient. That's why B cannot be an answer. Is it clear? Then at equilibrium, when the temperature is 340, the total pressure is 20 atm. The mole of each component present at equilibrium are shown in the table. You have moles at equilibrium, 0.515 moles, 0.23 moles, mole fraction. How to get the mole? What's the mole fraction of hydrogen? How to get the mole fraction of hydrogen? It's a moles, like if I need a mole fraction of hydrogen, it's a number of moles of hydrogen divided by total number of moles. So number of moles of hydrogen are 0.32. The total number of moles, what are the total number of moles? It's 0.15 plus 0.32 plus 0.18. So 0.49 or C will be the answer. Next, the numerical value for equilibrium partial pressure of carbon monoxide. How to get a partial pressure? The mole fraction multiplied by total pressure. So after getting the mole carbon monoxide, so mole fraction is 0.23 multiplied by total pressure, which is given 20. So 0.23 multiplied by 20 atm, you will get the partial pressure for carbon monoxide, which is 4.6. And then you will substitute the value for Kp, which is a product, the unit of Kp. And what are the unit for Kp? You can write an expression here. What will be the unit for Kp? So as Kp is a product divided by reactant as well. But the pressure of a product, so it's equal to pressure due to CH3OH divided by pressure due to carbon monoxide plus pressure due to hydrogen. But because its coefficient is 2, so it will be square. Here it's not plus, it's multiplication. So just substitute the values for their pressures and you will get the value for Kp. What's the answer for this question? The unit we need. So ATM minus 1 will be there. Minus 2. Question 6. The equation between carbon monoxide and hydrogen reaches a dynamic equilibrium. Dynamic means that reaction continue, but the concentration does not change. Which of the following statement about the dynamic equilibrium is not true? So the term dynamic equilibrium means rates are same, not the amount. That's why C is not a true statement. Statement D means equilibrium can be approached from either direction. What does it mean? Like example, if I originally have methanol, the methanol can form carbon monoxide or hydrogen, and there will be a stage when we reach equilibrium. So if I start with methanol, I will get carbon monoxide and hydrogen, and a time will come when the rate of forward and the backward reaction will be same, so I will reach equilibrium. Or if I start, I don't have methanol, or originally I have carbon monoxide and I have hydrogen. If I react both of them, what it will form? It will form methanol, and we will reach a time when the rate of the forward and the backward reactions are same. So we will say we reach equilibrium. So equilibrium can be approached from either direction. Means if I start with the original reactant, a time will come when I reach equilibrium. If I start with the formed product, a time will come when they will reach equilibrium. That's the meaning of equilibrium can be approached from either direction. Is it clear? Then some structure questions. So nitrosyl chloride NOCl is a yellow gas which decomposes on heating. A sample 2 mole of NOCl was heated in a sealed vessel at a certain temperature T. The volume of the vessel is 5 dm cube. When equilibrium was reached, 0.22 moles of NO has been formed. Write an expression for Kc. So what will the expression for Kc? It's a homogeneous equilibrium. So it will be product divided by reactant. So it will be NO concentration. You have to use the square bracket is important. Don't use a curly or a curve or a round bracket. The concentration of chlorine divided by concentration of NOCl. Calculate the value of Kc under these conditions and 4 marks. So it's how to calculate the value of Kc after writing the expression for Kc? So first we should know the moles at equilibrium. If I write this equation, NOCl, NO and Cl2. How many moles are there in the beginning or initial number of moles? NOCl, a sample, 2 mole of NOCl. So originally 2 moles. Heated in a seal and at equilibrium. So originally there was no product. But at equilibrium, when equilibrium was reached, how many moles? 0.22 moles of NO were there. So 0.22 moles of NO were there. So we should know the moles at equilibrium. First, we'll find how many moles of NOCl reacted. What is the ratio between NOCl and NO? The simplest ratio between them is 2:2 or 1:1, I can say. If 0.22 moles of NO are formed, how many moles are reacted? X. Cross multiply, same number of moles have reacted. But we don't need number of moles of reacted. We need how many moles are left at equilibrium. So what you will do, that's originally it was 2 minus 0.22, which will give 1.78. So how many moles of NOCl will be there? You will have 1.78 moles of NOCl at equilibrium. Then the ratio between NO and Cl2, the ratio between them is 2:1. So if 0.22 moles of NO are formed, how many moles of Cl will be formed? X. Cross multiply. So when you cross multiply, it's 2x is equals to 0.22. So 0.22 divided by 2, which will give 0.11. So how many moles will be there, which will form 0.11 moles of chlorine will be there. So 0.11. But these are the moles. Initial mole, equilibrium mole. But when we write the expression for for Kc, we use the concentration, not the moles. So you need a concentration. So concentration is mole divided by volume. What is the volume? Divided by, so each of them should be divided by 5 to get the concentration. And after getting the concentration, substitute in the formula, the equation for Kc for this specifically, this equation from this one, and find the value for Kc. Is it clear? The volume of the vessel containing equilibrium mixture was double. Like originally it was 5, now it is 10. Keeping the temperature constant, temperature does not change. Stayed effect on this change in a volume on the value of Kc, on the number of moles of NO, and calculation is not required. But justify your answer. So how you justify your answer? First thing, as we discussed earlier, the value of the Kc and Kp is not affected by changing the volume, changing the total pressure. It is only affected by change in temperature. So first the value of the Kc will be constant. Or same you can say, because it only changes with temperature. But what about the volume part? Because we change the volume. So if we increase the volume, what does it mean? We decrease the pressure. And if we decrease the pressure, equilibrium will shift towards side where number of moles are more. So which side we have greater number of moles? Because we have greater number of moles with side of a product. So more NO and Cl form because the pressure is reduced. The reaction goes to a side where number of moles of gas are more. So increase in volume, decrease moles, increase in pressure, increase in volume, decrease the pressure, which shift the equilibrium towards side of more moles. So amount of NO and Cl2 increases. This is about entropy, because already we discussed entropy as well. In this question, methanol is synthesized by the following reaction. Carbon monoxide plus hydrogen gives methanol. A mixture of 39.5 moles of carbon monoxide mixed with 77.5 moles of hydrogen allowed to reach equilibrium at 500 Kelvin and 50 atmospheric pressure. Under these conditions, the equilibrium mixture contains 38.5 moles of methanol. Write an expression for Kp. Kp is the product divided by reactant. So it will be Kp is equals to pressure of methanol divided by pressure of carbon monoxide and pressure of hydrogen square. Then complete the table, hence calculate the value for Kp. So complete this table because the ratio between them, as you can see, originally is 39.5, 77, 0. At equilibrium 38.5. So how many moles of hydrogen? So to know the moles of reactant at equilibrium, it's the original mole minus the reactant. So we have to first find the reacted mole. So how to find a reacted mole? By taking a simplest ratio, but 2:1 is the ratio according to equation. So if 2:1 is the ratio, if we have 38.5 moles, then this will be X. Cross multiply. So this will 38.5 multiplied by 2. That will give you how many moles reacted, but you don't know how many moles react. You don't want how many moles reacted. You need how many left at equilibrium. So originally 77.5 and reacted 77. So you're only left with 0.5. And then the ratio between them is 1:1. So if 38.5, same 38.5 moles will be there for carbon monoxide, and 38.5 minus 39.5 minus 38.5. So you will get 1 mole. And then you just substitute, but it's a pressure. So how to substitute? You will find the partial pressure for each gas. You will get the pressure of carbon monoxide which is a number of moles of carbon monoxide in the mixture at equilibrium, divided by total number of moles multiplied by total pressure. Then you will get the partial pressure of hydrogen, which is number of moles of hydrogen divided by total number of moles multiplied by partial pressure. And you will get the number of partial pressure of methanol, which is also in vapor state. So it's number of moles of methanol at equilibrium divided by total number of moles multiplied by partial pressure, which multiplied by total pressure. You'll get the partial pressure for each and then just substitute in the expression for Kp to get the value for Kp. Is it clear? Any doubt in this part? Any doubt in this part? Okay. So I will share this assignment so that you can solve. And if you have any doubt in this, you can ask your doubts related to this assignment.